días y bienvenidos. Good morning and welcome to the inaugural conference of the Mexican Society for Metaphysics and the Philosophy of Science. Our first speaker this morning is Dr. Paniel Reyes Cárdenas from the University of Sheffield in the UK, and he's going to speak to us this morning on the mathematical theory of continuity and its applications for irreversible processes. He'll speak for about 30 minutes, and afterwards we'll have a chance for 1 or 2 questions. Thank you.
Can I say a word of thanks to everyone again, just to turn up to this event. We are delighted to have the opportunity to showcase our research, which is like at the beginning of a bigger project, but hopefully. But this is related to my PhD thesis in a way, but it's actually not. My PhD thesis is something that I aim to develop as I hopefully, I get a grant for postdoc. So if I got it, it'll be probably stuff related with this topic. Next, please. So I like to start off by establishing some distinctions. One of the distinctions I wanted to mention in the beginning is we're going to try to narrow down what we all have a metaphysics, because the metaphysics is a philosophical theory that we perhaps consciously or unconsciously hold. But you always have to do some distinctions and specifications in order to avoid misunderstanding. And I like to do some very brief metaphysical distinctions first, then I'll give some bullet points on what the reversibility processes are and how the mathematical theory of continuity can shed a lot of light into the matter. And this is somehow just going a little bit ahead of myself. The conclusion will be that there is a way of helping ourselves to do inquiry in physics by having a better backdrop of our beliefs related with metaphysics and how mathematics and science interact in different ways. So this overlapping will be my interest. So having said that, I like to, give this distinction. So I want to oppose or resist. I like to resist the view that metaphysics is something that has to be formulated after, completely dependent into the sciences. Because when we do science, we also have some supposed metaphysics, some working metaphysics that we take for granted one way or another. So I believe it's always good to make a specification of our metaphysical beliefs before starting. So that this is an opposition to positivism, to some kind of neo-positivism that'll make metaphysics completely dependable into science, into the practices of scientific work. And then I want to oppose the other idea as well, like the rationalist idea, that is that metaphysics is open above every kind of scientific practice, which is also, I think, it's an ill-conceived conception of how science works, because it's pretty much what we criticize about big systems that haven't got a grip into reality or into how we know the world, and kind of drift away in different ways from science. So in a way, for example, let's say if we are married to a particular metaphysical system, and then that system seems to be consistent with scientific data that we come across through continuous inquiry, we're not going to reject science in those grounds. We're going to try to sort of start a dialogue and see where the inconsistencies lie and develop. So in a way, what I'm trying to say in brief, sorry, that was a long introduction, but what I wanted to say is that metaphysics and physics are somehow continuous. So they give feedback to each other. That's the one important claim I want you to bear in mind. Okay, so that's them two points, and also say this is probably more important, that metaphysics not only concerns what we know now. Well, this is just a general metaphysical statement, but I think it's going to be useful along the way. So, when we practice science, when we carry out scientific inquiry, we normally try to give sense to phenomena that we come across. And by doing that, we call them phenomena, we call them observables. Those phenomena seem to have a particular phenomenological character that we can account for. Does that make sense? But the theories that we formulate, the theories that by which we explain them observables, are theories that have entities and concepts and relations that seem to be pervasive to inquiry. They are recalcitrant to our research, and that we need to take on account, for example, laws of nature, laws of physics, laws of logical concepts and things like that. We call them beables because we say they have some kind of being. And these beables, they seem to be necessary for our inquiry. So that's an important thing to bear in mind. And with this, the corollary of this is that the observables are the thing we say they exist. Bless you. And the beables are the things that we say we know they are there because their reality is pervasive. So the necessity of giving account of the observables. So beables have reality but no existence. It's a particular distinction between reality and existence. And observables might have existence, both existence and reality. It's just an introductory, concept that might help us along the way. Thank you. Next slide, please. Yes. So, for example, beables might be dispositions, habits, laws, entities of all sorts. Even observables are beables because they have being. So anything that is object of metaphysics is something that has some kind of manifestation of being. Unobservable are items known in the continuous experience of beings. They resist those as phenomena. I know that this table exists because if I carry on walking that way, there's some kind of resistance that I'm going to find eventually. I'm not going to give the example now, but the idea is that we can have this. We know them by their resistance they exert to us. So, but that goes for a range. I mean, the range of this, the scope of beables and observables as a ontological furniture is really high. I mean, it's really wide. We can even think about, quantum particles or things like that, all the way up to galaxies, and all of them, there is a sense in which they are beables and observables. Next, please. Now, what I'm trying to suggest is that the mathematical theory of continuity, the reality of continuous, remember, not the existence, the reality of continuum series, can help us to understand some kind of particular physical process that we will call irreversible process. So the mathematical continua, let me just define what these items are divisible without limit or infinitely divisible. The unity of a continuum conceals a plurality that can go all the way to infinite. Okay, next please. And then, this probably is related with my PhD thesis. And then somebody who explored how the mathematical theory of continuity could be applied in all sorts of manners, and particularly in the relationships between philosophy and science, was Charles Sanders Peirce, an American philosopher of the 19th century. Peirce's conception of the number continuum is also notable over the presence of the abundance of infinitesimals. Peirce championed the retention of the infinitesimal concept in the foundations of calculus, both because of what he saw as efficiency of infinitesimal methods he carried out in researching pendulums and gravity, gravitation in different geographic areas of the Earth. So he needed to have a good account of vagueness in scientific data, as well as a good account of observers. So, and then he regarded the infinitesimal aspect of series as the glue, that seems to give unity to some phenomena, or that seems to explain or give an account for some phenomena that we might observe. Next, please. Now, this is the technical part of the talk that I probably will skip very. But let me just give a general gist of what it's about. So, when we talk about continuous series, for example, we try to think in terms of mathematical structures that have a smooth character. They might not bend or broke. This is a very technical use of the words bending or breaking. But the idea is that, think about the natural number series. We all know that one, don't we? 1, 2, 3, 4, and so on and so forth. Okay? Is there any end to that series? No. Is there any essential? Is the series the result of the sum of all its members? Maybe. But maybe some might think that you could have it. But if you needed to know the sum already in order to use the series, then no, because it's impossible to have the sum of all the infinite series in your mind, as it were. So, what we try to say is that the natural number series is a continuous structure. And we don't say that it's composed of numbers. The numbers are not the components. The numbers are points, that express a place in the structure. But the properties of the numbers, in particular, are completely dependent in the properties of the structure. So you have, from a metaphysical point of view, when you want to define a series, you have to think in the continuity of the series before thinking in the particular points, as opposed to thinking in all the numbers of the series and then, oh, this is a series. That's the idea. Okay, try to, and then I hope that's enough to skip the mathematics. Can we go to the next slide, please? And then this is how the elements work in mathematical equations and things like that. But I think I should skip this now for you to not sleep in the first talk. Next, please. Now, what actually concerns me is that in physics, some processes seem to have the property of irreversibility. Am I doing on time? So, in nature, we seem to be witnesses of natural processes that are irreversible. There are cases in which an event and the other event that seems to be its cause, they're not reversible. See what I mean? One of them, irreversible processes, for you to understand what I mean, is me losing my hair, for example. That's an irreversible process, apparently. Because it's a process of nature that doesn't seem to, no matter how do I, how much I cling to each of my particular filaments of hair, pigments of hair, eventually I will lose it. So it's better resignation. Anyway. Well, now, being serious, that happens in a lot of physical processes. So people who is familiar with engineering, engineers here, might understand that the second law of thermodynamics has an irreversible character. The law of entropy is irreversible. We can't really stop it. You can't resist it. You have to let yourself go with the flow, as it were. So I'm just going to read this to not skip any important concept because there's a definition there. The phenomenon of irreversibility results from the fact that if a thermodynamic system, which is any system sufficient of complexity, I'm talking about systems with a lot of variables, okay, interacting molecules, is brought from one state to another. The configuration or arrangement of the atoms and molecules in the system will change in a way that is not easily predictable. So we have the laws of gases, for example, and we might as well say, oh yeah, but that's actually quite predictable. Yes, it's predictable up to a point. But if you wanted to predict where exactly a molecule is within the context of a gas being pushed or sucked into a device or something like that, you just can estimate statistically what is going to happen with the gas. There is always going to be some room for error, in our calculations in an irreversible process. But that's vagueness, that is part of the process. But also it's irreversible in the sense that there are many ways in which we cannot imagine a state in a statical manner. All right. Okay, next, please. And this was discovered pretty much in the second half of the 19th century. In the physics of those years, they witnessed the difficulty of accommodating problems of energy physics, particularly. They realized our classic Newtonian framework seems to be not good enough to account for this irreversibility. And there is an aspect of irreversibility that you might be having in your intuitions right now. And it's, the most clear example of irreversibility is the arrow of time. Is it not? The arrow of time seems to be irreversible in this definite sense, like a strong sense of irreversibility. And the universe, as it develops, it seems to have this aspect. So, the Newtonian physics framework, physics, there's an H lacking there, that was also known as mechanicism. Was inspiring the idea that everything in the world was like engines with meshes, working in a particular direction. But there's nothing for you to think otherwise. For example, think about the second law of Newton. Time is a positive variable, is it not? Time is a positive variable, but it's a square. So you could perhaps try to speak about negative time using Newton's laws. There's nothing for you to avoid it. And that was a big problem in the 19th century. So the best we have is Newton's background, the classical mechanics background. But it doesn't seem to be enough, to explain how the arrow of time seems to be irreversible. I'm not going to go down to the details of these because I don't want to bore you and the time is short. But the idea is that there's not enough material to explain how the arrow of time is. How can we know? How is it so clear to us that we cannot reverse some processes. So those are some problems that are bottom line problems of the metaphysics that is at the base of the mechanicism of the law of the Newtonian classical background. Next, please. 10 minutes. All right. So I'm just gonna try to give an update on how this works nowadays. And yeah, time appears with some characteristics from the viewpoint of the laws of mechanics and the principles of energy physics. So we do have an account of time coming out of this background, but it doesn't seem to be. The old paradigm of mechanics that proved itself insufficient to explain energy physics and arrange cages belonging to, for example, gravimetrics, electromagnetism, and quantum physics. And there's an anecdote of Maxwell, for example, when he developed the mathematics of electromagnetism. He used to say, I will be better off if Newton was born, you know? Because it was so difficult for the people to understand his mathematics, because they had a fixed idea of, you know, some variables being completely permanent in the sense that was for Newton. And it was really difficult for them to try to have the flexibility to understand that there are things that act in the world without being solid objects, as it were. Okay, next please. That's obviously a quick summary. Obviously there might be objections to that. So, just to summarize this, the first important problem in the paradigm of mechanistic physics lies in the inability to distinguish between forward and backward flow of time. The existence of this flow as time reversal invariant. Okay, next please. I'm gonna just skip more details on that. So now the point of this is how can we use the mathematics of continuity, the syncretism we talked before, into this, you know, to get a better explanation. So physicists say that one of the properties of our universe is or cosmologists particularly, and isotropy. And this is that the arrow of time of the whole universe seems to be irreversible. That doesn't mean seems to be constant, because they are, you know, relativity theory accepts that, you know, depending on your point in space, you can have a different perception of time, having in the background that the only constant is the speed of light, or the velocity of light. Okay. So this is important metaphysics in this, hopefully. So the directionality of time is a continuous process, you know. Space and time are a continuum, and time is not a property of particular events, discrete events, because all the events, there is a sense in which all the events in the universe are connected. So there is a sense in that continuum is uninterrupted. So from my epistemological point of view, I tend to think that my getting up, you know, from my sleep and having my breakfast are two different events, you know. But because it's useful to me. And then if somebody asks me, my mom asks me, have you had your breakfast? I can't answer, well, I'm still in a continuum with my sleep, so I can't really respond to you. Obviously, that would be silly. But the point of this is, obviously, we're not going to go about in the world saying everything is a continuum, you know, we are strict monist, so you are not different from me, we are the same. Well, that would be an exaggeration, you know, and because the continuum, that everything is within a continuum doesn't mean that everything is has the same variation and it has the same expression and manifestation of that continuum. So that's why gravity, for example, if it's understood as a warp, in space, in the continuum of space-time, it does make a difference. It does make a difference. That's why black holes trap light, for example, supposedly. If we conceive time as a property of the universe as a whole, more when we try to explain the anisotropy and the arrow and the irreversibility of the arrow of time, we're better off than conceiving time as the simple variable of the events that we observe. So there's no particular time for the events. When we try to conceive the universe as a whole, the universe is not the sum, it's not the mereological or the purely logical sum of particular events, but it's actually a continuum. Okay? And this is, by the way, it has to be said that this is a good response, for example, to the paradox of Achilles and the tortoise, because, or the arrow, that then paradoxes, you can have a good response to those paradoxes because they're like, well, as the arrow goes in the air, it doesn't have to, go by an infinite series of particular points, because the continuum for space is not the sum of the space points. Points are eight-dimensional. They're just indexical conventions that we have. So the universe is not the sum of discrete elements. It's more continuous, and this helps us. This is proven. You might say, "Well, Paniel, that's quite trivial, really. It's like there's not much science in this." Well, but you might be surprised to see how this, background of, let's call it, atomism of space and time has affected science. So it's important, I know this probably a trivial point at this moment, but if we want to go deep into the explanations of how this continuum behaves, then we use the mathematics of continuum. And with those tools, we can do better science, as it were. So I'm just going to try to, recapitulate, because I just have 2 minutes now. So that explains how some processes are irreversible, because the property of time is not a property of particular processes scattered around the universe, but it's a property of the whole universe that is going in a particular direction. Can we go to the next slide, please? So these are some useful arrows to bear in mind. Some arrows. For example, the cosmological arrow that goes from the time of the smaller universe to the time of the larger universe. The thermodynamical arrow that goes from less entropy to more entropy. And then the psychological arrow, which is our perception of time, that on events that happen and events that haven't happened yet. Does that make sense? So what I propose you, just to summarize my talk, is to imagine them arrows. All the arrows of different times, they are like strands in a cable, as opposed to a chain, This is a metaphor of peace philosophy first. I want you to conceive time, the general arrow of time, not as the sum of this arrow, but as the kind of overlapping of different arrows. And as we develop our sciences, we can sort of, identify where an arrow is coming from and more or less how it's interacting with others. But this is a continuous process. There's a lot of vagueness going on in the relations between the different arrows, but all of them, curiously enough, are irreversible. Next, please. So that is my proposal, in a few words, try to use the mathematics of continuity into physics to, get better conceptions of, but avoid the atomistic scruples or the nominalistic, in some way, scruples of conceiving everything as discrete and completely atomistic or unrelated with the other. Next, please. So this kind of becomes into a new paradigm, and that, in a way, brings together in a closer way mathematics, philosophy, and science. Next, please. Yes, this is saying the same. And these are some suggestions of how to carry out that use. And these are the conclusions. Sorry. So the conclusion is that we have a fact in our, say, a recalcitrant fact in science, that is that there are irreversible processes, and the irreversibility of those processes seems to be somehow manifested in the reversibility of time. Not necessarily, it's not the only one token, you know, there might be other examples of irreversibility, but time is a more intuitively familiar to us. So it renders us an explanation of that has these two elements of our ontology, beables and observables. And then continuity is a mathematical account that kind of helps us to explain that in a better way. And next please. And so with this, I give you thanks for having your patience on me. And sorry about the oversimplification of some of the points. Thank you ever so much.
¿Puedo hacer la pregunta en español? Sí. A mí me queda todavía muy claro por qué la continuidad implica irreversibilidad. Me gustaría, a lo mejor, si puntualmente me pudieras explicar, bueno, dar un formalismo matemático donde esto se vea claro. O sea, digo, no que ponga la fórmula, sino ¿qué tipo de formalismo, en qué tipo de formalismo esto se expresaría? Porque yo no veo claro que moverse de lo discreto a lo continuo implica irreversibilidad.
Bueno, la idea es que cuando tú comienzas a hacer una expresión matemática de un evento, tienes que suponer que el evento está de algún modo conectado a eventos previos y a eventos posteriores. O sea, no está aislado. Conceptualmente, jamás aislamos, una ecuación jamás aísla completamente un evento, o lo que queremos llamar nosotros, en nuestro conocimiento del mundo, evento. Y de esta manera, bueno, ahora, lo que te da, la herramienta que te da las matemáticas del continuo es una manera de asumir esa continuidad que está antes y después, sin afectar sin perder la capacidad de tener una buena respuesta o una buena explicación de ese evento. Pero esto sí asume que nuestro conocimiento siempre es aproximativo. O sea, nunca tenemos un conocimiento absoluto ni de un evento, ni siquiera del universo como totalidad. Siempre estamos como en un proceso de ajustarnos con lo que está pasando.
En algún momento dijiste algo que sí me sacó mucho de onda, que es que había una primacía del continuo sobre cada uno de los números naturales. Sí, pero bueno, te voy a enfrentar nada más con los viejos argumentos wittgensteinianos, ¿no? Bueno, podemos tener series de números naturales que no sean continuos, ¿no? O series numéricas que no son continuas, ¿no? Vamos a tener 1, 2, 3, 4, muchos. Y sería muy difícil decir que ahí el 3 o el 4 son distintos que el 3 y el 4 que nosotros utilizamos, series continuas tenemos. Entonces, eso te presenta con un dilema que me parece un poco pues incómodo para ti, ¿no? Porque por un lado tendrías que aceptar que la gente que no tiene el continuo tampoco tiene números, aun cuando sea capaz de contar de una manera rudimental, o que, pues bueno, que no es cierto que hay una primacía del continuo, ¿no?
Ok, sí. Hay dos aspectos de las matemáticas, ¿no? Cómo las conocemos y cómo sus conceptos pueden explicarse de distintos modos. Cierto, o sea, hay maneras de representar las series sin atender a sus propiedades en el continuo. Pero lo que yo sugiero es que si tú puedes usar ese sistema de matemáticas, pero si lo usas irreflexivamente para todos los casos, corres el riesgo de olvidar que en procesos irreversibles de la naturaleza, nuestro acercamiento matemático al mundo funciona mejor si es con series que son continuas, en el sentido de continuas con capacidades infinitesimales.
No, la idea no es que los números de hecho son así, lo que deberían ser.
Bueno, la idea es que podemos entender los números de distintas maneras, pero que para ciertos casos, es un argumento pragmatista si quieres, para ciertos casos es mejor usarlos en este sentido porque su poder heurístico es mucho mayor.
Gracias.
Ok, muy rápidamente. Es muy interesante la propuesta y presentas aquí, pero quisiera más claridad sobre un punto en particular. La aplicación del continuo para explicar la irreversibilidad de ciertos procesos, ¿presupone acaso una concepción ver el tiempo, o por lo menos tiene acaso más armonía
con alguna idea de cómo el tiempo, con una metafísica del tiempo?
Una metafísica del tiempo, exacto. Sí.
Bueno, esa es una muy buena pregunta.
Theory versus A-theory.
Ajá. Bueno, hay, un poco para la información del público, hay como dos grandes concepciones del tiempo, ¿no? A ver si lo puedo resumir muy rápido, bien, y si no me corrigen. Una es que el tiempo es una línea con puntos en los que nosotros nos encontramos en determinado tiempo. O sea, que nosotros recorremos, pero la línea misma tiene un carácter estable y nosotros, como agentes de conocimiento, recorremos la línea. Y otra es que el tiempo, como una idea de que el tiempo es un flujo que puede acelerarse o no, pero que es continuo y que siempre está fluyendo. Y bueno, y esto obviamente tiene como distintas respuestas a otros problemas que si pudiera, por ejemplo, híjole, no quiero ir en detalles, pero sí, quisiera, bueno, si hubiera si fuera la A o B, yo diría que es más la teoría de que el tiempo es como un flujo.
Gracias por la charla, estuvo muy interesante, y mi pregunta en realidad es mucho más básica de las que te he hecho hasta ahorita. Mucho más básica, pero con esto no quiero decir que sea más sencilla responder. Te voy a explicar por qué. Porque si tú supones que la teoría del continuo matemático te sirve para tener buenas explicaciones sobre el mundo físico, entonces supones de alguna manera alguna relación que existe entre las estructuras matemáticas con el mundo físico. Entonces, en este sentido, me gustaría saber tu punto de vista sobre cuál es la relación que tú supones que existe entre las fórmulas matemáticas y espacios que no son particularmente matemáticos. Ahora, justifico mi pregunta en el siguiente sentido. Creo que este punto es importante porque, por una parte, tú tienes que mantener que sí hay una diferencia entre la teoría matemática como tal y la aplicación que haces de esa teoría para dar, como tú dices, una explicación, una aproximación de un evento físico. Entonces, por una parte, tu respuesta tendría que decir, claro, las ecuaciones o el lenguaje matemático tienen tales propiedades, y por otra parte, aunque haya continuidad de la teoría matemática para explicar el mundo físico, también tendrías que decir que la estructura física tiene propiedades diferentes. Entonces, mi pregunta concreta es la siguiente: ¿qué es lo que tú piensas respecto a la relevancia entre las ecuaciones a nivel epistemológico? ¿Cómo tú puedes conectar las ecuaciones en términos matemáticos con una buena explicación de un hecho que no es matemático?
Lo que podría yo decir es que una creencia que de algún modo supongo en esta presentación es que entre la continuidad que expliqué entre metafísica y ciencia, lo que media esa continuidad es las matemáticas. O sea que cuando nosotros hacemos ciencia o cuando hacemos filosofía, particularmente metafísica, lo que estamos haciendo es un tipo de identificación de
cuáles son las estructuras que en el fondo son matemáticas. Lo que quiero decir es que nuestra epistemología es, entre más refinada sea, más matemática se vuelve. Porque las estructuras metafísicas, su mejor expresión es como estructuras matemáticas.
Yo compartiría un poco esto, pero sí, eso no es obvio.
No es obvio, no. Por lo cual, yo creo que tu plática va a iluminar muchos puntos de... Porque es de homomorfia, ¿no? O sea, como estructuras tienen propiedades similares.
Muchas gracias.
Gracias.